Am I streaming? Oh, yes, I am. Something, something in the way, draw loops. Attracts me like no other function. Oh, I can't get anything right. Nice. Okay, let's try that again. Something in the way, draw loops. Attracts me like no other function. Something in the way, draw loops. I don't want to stop coding now. You know I believe in how. This song is dedicated to processing my first love, my one true love. Happy February 13th. One of my favorite days of the year. For some unknown reason, I'm not sure why. Did you hear that rattle? I haven't used the ukulele because it has a weird rattle. And so me being the mechanically minded person that I am, very mechanically, really good with tools and building and putting things together. That's sarcasm you hear in my voice. I'm terrible at all that stuff. I found this screwdriver and I tried tightening all these different screws that I found all over this thing, but I don't know. Still rattles. So if anybody wants to submit other love odes to processing, or maybe to P5JS or other types of programming things, I will sing those later on today's heart-themed coding train episode. All right, so welcome. Good morning. My name is Dan, and welcome to the Coding Train. This is a live YouTube stream that now happens every Wednesday at 10:30 a.m. Eastern. Can you believe that? I have an actual regularly scheduled time. So all of you who have been asking, just come here next week at this exact time, and I will be here. Except for when I cancel or something happens, and then there's like a snowstorm, or I'm sick, or like a meeting came up that day and I have to do it on a different day. But hopefully, I can't bring myself to actually put on the top on the YouTube banner like live every Wednesday at 10:30 a.m. because I'm afraid that will jinx myself. But that's my plan. So yeah, people are. Eric is asking, shouldn't the yellow colors fade to blue as time goes on? Alexandra is asking, hey, it's probably from the nut or the action. You should check the trust rod. I have no idea what any of that stuff is. I hope that's not like, but that probably has to do with parts of the ukulele. So this is this is the result of the coding challenge that I did last week, and I don't remember what the settings here are somewhat arbitrary in terms of the fading and the in terms of some of these values. Let me run this again. So I kind of wanted to continue with this week, but I don't know. Things didn't go well for me in the last week after putting this code together. But I do want to talk about how I still want to do some follow-up videos about that. So let me begin by talking a little bit about fluid simulation and where my head is at with that. So I want to talk about a few things. So this is, what you're seeing here is the result of me porting code from Mike Ash. It's a blog post called Fluid Dynamics or Fluid Simulation or something like that for Dummies. That code, that blog post was written based on the sort of seminal paper from 2003, I think, Real-Time Fluid Dynamics for Games by Joss Stam. And so this is like kind of a 15th generation version of that in processing. And it works in this nice way to create this fluid-like feeling. I mean, the visual appearance here is much more like smoke, but with changing the way you render the design, changing the various parameters of the design, you could probably create a variety of different kinds of fluid-like simulations. However, this is not, many people have gone before me to create versions of this in more thoughtful and sophisticated ways. So my original plan was just to port the code, which I did. The next step, I was going to try to refactor the code. And I started working on that a little bit, and I want to show you where I got to, because maybe some of you might have some suggestions. So I'm going to go to github.com/Schiffman/CFD. The CFD stands for Computational Fluid Dynamics. And these were some test bits of code that I put together before I did the actual live stream. If you want to find the actual code from the live stream, you can just go to here. You will see the video here. This is on thecodingtrain.com. This link will take you, this link will take you to the code. And then, one person. Ooh, this is exciting. We have one community contribution. So let's take a look at this community contribution really quickly from Juan Carlos Ponce Campuzano. Flow around circle, incompressible, non-viscous fluid. Oh, I love this. So this looks like it is a particle-based fluid simulation, which is really where I want to get to with all this stuff. And you can see the path of these dots kind of moving around this circle. Can I move that circle? Oh, I can move the circle. That's kind of cool. I might suggest, it sort of surprised me that it went the color of the background when I clicked it. So I might, if I were giving my quick off-the-cuff feedback here, I might consider a different color change for when I click and drag. But I can, let's click on trace. So that's cool, so we can see the trails of these particles. Let's click on speed. Oh, it says drag circle right there. What does radius do? Oh, that makes the radius of this. Interesting. Oh, much smaller. So let's make that big. Let me drag it around. Cool. So that's great. So I'd be curious to look at, I would love some documentation here about, and I wonder, it's probably in the source code if I click here, some documentation about what algorithms led you to this particular simulation, or did you invent them yourself, or what was the sort of technique employed here? That's terrific. Okay, so, but where I was getting to is, over here, I started refactoring the code. And if we look at my code from last week, which is just, again, a port of other people's code, what you'll see is that, let me go here to the fluid class. What you'll see is all of the data that's part of this fluid simulation is a set of 6 different individual arrays. There is a velocity vector associated with each spot on the canvas, each spot on that grid of pixels. And that velocity vector is described by an x and a y. This 0 notates the sort of previous velocity vector. So we always need to know historically what was the velocity before this moment in time. And this is very common in a lot of different cellular automata algorithms that involve data on a grid. And then also there's this idea of density, which I might think about renaming to dye, because it's the amount of dye at any spot in the fluid, and that's how we end up visualizing whether we map that amount of dye to a hue or to a brightness value, and then S is the previous amount of dye. So I had this idea that let me, and I was going to do this live, but I thought I would sort of like try the first steps of it, which you can see here, and this is my fluid refactor, and if I go here, I had this idea, okay, well what if I had like this idea of a velocity object, and it was actually a p-vector object, and the velocity object knew a current velocity and a previous velocity. So A, I'm just like trying to get some new variable renaming to make the code a bit more readable. But also, and then if I had a dye object, which would just be a scalar, so the velocity object is a vector, the dye object is a scalar, and then this would allow me to have the fluid class have just these 2 arrays, like the array of velocities and the array of dyes. And then I could start, the code would sort of like simplify into like this. I kept going down this road, and this doesn't work, but then this is my idea. Oh, then I could apply the different steps of this particular simulation. Diffusion, projection, diffuse, project, advect. And I would diffuse and project the velocity, and advect and project the velocity, and diffuse and advect the density. And then I started realizing, the whole way the code is written if we go into those functions that perform these operations, is to operate off of a single generic array. So I guess I could overload the function, have two different versions of each functions, whether they're getting a vector or an array. Then I started to get lost, and I was like, I don't know the best way to do this. And that was like late at night last night. I was like, I have to live stream about this tomorrow morning. So rather than take up all of today's live stream trying to refactor this code, what I'm asking for you is your suggestions. So if you're watching this right now and want to think about this, have some ideas for me, let me know. Because my goal is to refactor it in a way that's more readable, maybe turn it into a library, maybe port it to JavaScript, maybe optimize it. There's lots of possibilities here. But then I was sort of thinking, what am I doing here? Am I really the person in the world who's going to invent a new fluid simulation library and algorithm and organize it? I mean, probably not. To me, maybe. And certainly with the help that I've found with this wonderful internet community of people who watch this channel, I'm sure there are lots of people watching who really could thoughtfully contribute to this idea. But there are many other, this is not a new idea. And in fact, researching this a bit more, I found another library called PixelFlow. Its last commit was pretty recent, so that doesn't, oh no, that's not pretty recent, that's a year ago. Its last commit was a year ago, but you can see it has a lot of functionality for these ideas. If you can download it, and I actually ran some of these examples, which are quite, oh, here we go, which you can see are quite exciting and amazing. So this is an interesting possibility for me to look into actually just using a library where all of this has already been sort of refactored and reorganized in a way that makes it useful for like making the projects. There is also MSA Fluid, which is a library that I used many years ago, which is the exact same algorithm that I implemented, but thoughtfully packaged into a library, but not currently compatible with processing 3. I quickly checked. I think this would require a small amount of work that I could actually do to update it to work with processing 3 more easily. So that's a possibility. But I've been in touch a little bit with Gabriel Weymouth. Let me find Gabriel Weymouth on Twitter. Gabriel Weymouth is a researcher specifically in fluid structure interactions, based in the UK. This is the website. And Gabriel Weymouth has created something called a LilyPad processing, which is, and let me just download this. I'm gonna, let's take a moment, because this will actually just run right off the bat. So I'm gonna show this to you, because this is really, really phenomenal. And why is my ZSH broken? Let me actually go to the desktop and let me clone this repo real quick. Let me open here. And let me open this up in processing. I'm going to go to LilyPad, and I'm going to run this. So look at this. Let me zoom into this here. We can see we've got a really excellent and more dynamic and probably accurate fluid simulation here. And there's so much to this. Like this quick demo of this is like scratching the surface of what this example, I don't know what to call it, example, demo, open source code project does. But to me, and it's really well organized thoughtfully in an object-oriented fashion. But for me to use it and to like, there's just like so much going on here. And it's probably fairly well documented here. Documentation on the solver, guide to contributing to the project, simple instructions. There's lots of documentation here. But what I think might be useful would be to turn this into a processing library. And by that, I mean something that I can do actually just through here. Import library, add library. For example, if I look for PixelFlow, is it here? Yeah, PixelFlow is right here. So I'm gonna find PixelFlow in the libraries. I'm going to hit install. I'm going to install it. And then let me go find one of the PixelFlow examples. So I can go over to examples, and I can go to contributed libraries. I can go to PixelFlow. So we can pick any of these. Let's just try Fluid 2D, Fluid Basic. And then we can run this. And, so look at this. The package control P5 doesn't exist, which means this is dependent on another library. Let me quit these, by the way, because they're, so sketch, import library, add library. I'm going to add control P5, which is an interface library, which it's much harder to do interface elements in an elegant and flexible way in processing in P5.js because you're in the browser, being able to manipulate text boxes and buttons and sliders and create an interface. There's so many more possibilities given the rich set of features that a browser affords. Okay, so let me now try running this again. So there we go. Okay, so we can see this is a similar idea of yet another fluid simulation example. So, so this is where I'm struggling with how to move forward. First of all, I got a lot of stuff I got to do. I don't know how much time I can really spend on this fluid simulation. I'm so fascinated by it. I want to. Oh, I want to. So one path, which was my original path, was to kind of refactor my code, make it a little bit, try to understand how the algorithms work a little bit more and explain those things. That will take some time and research on my part, which is a little atypical for how I do things, which is more fly by the seat of my pants. So that's one possibility. The other possibility would be to leave that fluid video alone and go straight to using a library, whether it's PixelFlow, MSA Fluid, or LilyPad, all three. So that's what I'm looking for thoughts and suggestions about. But I'm going to leave that now. I'm like looking over here and I'm seeing someone say he is not looking at chat ? So no, I am not looking at chat, except for every once in a while when I do look at the chat. Okay. So I want to put that aside, and today I want to focus on the heart. So let me quit this. Okay, wait. Oh. Let's also go to the DVD logo challenge. Since there were several community contributions, let's take a look at some of these. So let's look first at Bouncing DVD Logo by Bruno in 3D. That's pretty great. That's pretty awesome. Thank you for submitting that. Let's look at Verlet DVD Logo by Anurag. This is cool. So it looks, add rope. There we go. So now these are, looks like Anurag, who created this, actually made an entire Verlet physics library, verlet.js. I typically have used toxiclibs.js for my Verlet physics. That's really cool to see the thing about alternative physics for this DVD video. Bouncing 90s screensaver. Beautiful. Let's see, what else do we got here? Bouncing DVD with corner detection and more. Oh, look at this. Oh, I love this. So it's counting the number of collisions, the number of corners. The corner threshold, I guess, is like how close does it have to be? The size is the size of the logo. The speed, let's make it go fast. All right. Come on, everyone. Wait, hit the corner, I missed it. Ta-da! That's it. Okay. And then changeable speed, track, and hit the corner detection by temporary pride. Ooh, I like this. Press T to enable, disable the track of the logo. Cool. Scroll the mouse wheel to speed. Oh, I love that. I can scroll the mouse wheel, which speeds it up or slows it down. And background switches if the logo hits the corner. Logo color switches if the logo hits the edge. So we know if it hits the corner. It hit the corner if the logo hit the edge. Wonderful. Okay, so thanks for those. I'm really trying to spend more time keeping this site up. And so each coding challenge has a card. First of all, thank you to all the people who have contributed to this website. This is not a project I made or designed myself. This is a community developed project. Let me just go to GitHub here and click on contributors. And I, rather than name people, I can just sort of scroll here and we can see a lot of people who have contributed to this website. So there's actually another project, which is a sort of like Coding Train website 2.0 that's on the horizon. But my goal is to really have a place for the community to be able to share work that they're doing, and for me to also make sure I'm crediting all of the different sources and things that I use. So for each, and in YouTube, the YouTube description works and the playlists work to some extent, but this is basically each challenge has a card. If I go here, I'm going to go to the DVD logo one, or actually let me just go to this Fourier transform one. So if I go to the challenge, this is the video obviously, but you can see here's the code. There will be, my goal is to have P5.js, web editor, and processing code for each challenge, and I know that David Snyder, a viewer, has made a processing version of this, so hopefully that'll get up on the site soon. You can download the code, see it live. I might need, I don't know if that's the right terminology, but that will just give you a link to the actual demo running in the browser, and then various other things that are related to the video are discussed here. And this is the important part that I wanted to highlight. This is where you can submit your own version. So right now, there's no kind of elegant, web form type thing. This is all has to be done through a pull request, which can be somewhat daunting and a little confusing how to do that. But these links will take you to instructions on how to do that. And don't be afraid. Come, we are welcoming and friendly in the Coding Train GitHub repository. If you've made something and you have no idea how to submit it, open up an issue, say you need help, try a pull request. Don't worry if it doesn't work, it breaks, there's a bug. Just give it a try. I hear this from so many people. Oh, I'm no good at that GitHub thing. I wish I could contribute something. Sometimes you just have to get over that first hurdle, and you need people to be there helping you get over that hurdle. And so Coding Train, there are lots of other places that are wonderful communities, open source communities, helping people to get started contributing. I hope that Coding Train can be one of those. So this is just my little pitch to encourage you to contribute. Okay. I'm not using a timer today. I will use my bell. Live demo. Yeah, live demo probably would make more sense. Mark Sheriff writes in the chat. That is a good question. Anwar Ben asks, do these live streams get saved in the channel? Yes. So let me take you to the Coding Train on YouTube. You can see here that I'm live streaming now. If you go back, I'm just going to go to uploads. Okay, all right, here's my videos. This is what you would get if you were not logged in to YouTube, and you would see all these different videos. What I'm looking for is, yes, so these are typically what the live streams look like. This is live stream number 100. The last one, we're a little bit behind, so you can see these are some recent live streams that don't have like a thumbnail and a title with a number on them, so a little bit behind at that. But the live streams usually get numbered. And then everything else on the channel is mostly redundant content edited out of the live streams. So as always, anybody has a suggestion for how you can organize this stuff better? Some people on YouTube have separate channels, one for live streaming, one for uploaded content. I'm just kind of doing everything all in one channel. It's in one place. Anyway, I'm joking. There's nothing there particularly private. I will just mention that I have some videos that are for a course that I teach at NYU that are unlisted because they're specifically only for that course, but they're just administrative videos. My sort of technique for the way that I do it is when I have content videos for a course, I have those public on YouTube. Okay. Okay. What am I trying to do? Right. So what am I doing today? What am I doing today? So I want to, let me pull up the, oh my goodness, Simon, wow. So first let me talk about Simon. Simon is a viewer of the Coding Train. I'm going to do Simon, and we're going to get Simon's YouTube channel, and we're going to click over here to Simon speaking at Processing Community Day. And I'm going to click over here, and I'm going to go to Mathologer, Heart of Mathematics. this particular video. Then I'm going to close this, and close this. So this is a very famous pattern in mathematics called the cardioid. There is a video on the Mythologer YouTube channel, which is a fantastic YouTube channel about mathematics, about using times tables to visualize this cardioid shape. The cardioid shape appears in the Mandelbrot set. It appears in diagrams of kind of light patterns. There's an explanation in this video of how you can see the cardioid pattern in the top of a coffee cup based on like the way the light bounces off of it and reflects off the coffee. All sorts of fascinating stuff here. Simon created a poster which I have downstairs hanging in my office. I should have brought it up here to show you. Visualizing all of the times tables in processing inspired by this particular video. And this is Simon giving a presentation about it at Processing Community Day, Amsterdam. So these are my two inspirations. I think Vi Hart also has some videos about the cardioid. And about, generally speaking, Vi Hart has amazing, wonderful, mind-filling, soul-beautifying videos about mathematics and different types of things. So I encourage you to check out the work of Vi Hart if you don't already. I should never look at the chat. So slow mode is not on again. I don't know why I'm forgetting to not put slow mode on in the chat. Oh well. We'll see if I need to. We'll see if I need to. We'll see if I need to pull this car over, kids. Pull the car over. So I would like to do this. And so, in honor of, I'm trying to avoid saying Valentine's Day, but I'm just going to say Valentine's Day once. In honor of tomorrow, I would like to make a heart. I would like to express my love for processing. And we're going to do that here by visualizing the times tables and get this pattern. And I would like to recreate the animation. I'll just click over to it.
Just to finish off, I'm going to show you a little bit of a movie of all the stuff evolving a little bit slower.
I'm gonna let this play. This is Mythologer's content, not mine. Mythologer here. So I'm just gonna let it play for a few seconds. So I'm gonna try to kind of recreate this animation. I'm gonna stop it now because I want to be careful about repurposing other content. Encourage you to go check out the Mythologer video. But I want to see if I can create my own version of this animation. Okay. Let me refresh this page. Refresh this page. There we go. Cardioid. There are lots of techniques for creating the cardioid shape. This being the most common. This is super related to the epicycles video I recently did. I don't know if it makes sense for me to make a video just programming this way of generating it, but it's useful to see that. And then I could also get, where's my Mandelbrot set challenge? I'm gonna have that ready to go. Let's see here. Here we go. Let's grab the processing code. Is that what I want? See it live. Let's do that. So, law. Let's grab the processing code. And see what happens here. Because why would I avoid Valentine's Day? The reason I would avoid Valentine's Day because it's a fake holiday. It's an excuse for corporations to sell greeting cards. Love is a real thing. I embrace hearts and puppies and rainbows and all of those things, but not this candy commerce nonsense. There's my... Okay, let's take a look at this. All right, so in processing, I should be able to make this, let's try to make this 1280, 960. Yeah, so there you can see the cardioid shape right here. And then, of course, what? It's been another half an hour? Jeez Louise, I gotta get started doing something. Get my ukulele out again. Okay. Why is this? Let's just do this. Okay. Have this. 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 I have this. I have this. I have this. Okay. What's interesting? What's here? What does machine learning think I should watch next? Interesting, fascinating. Okay. All right. So this is legitimately, sometimes it's not, sometimes it's something that I've programmed hundreds of times, not hundreds of times, but several times before, but maybe not in years. Sometimes it's something that I'm completely looking at for the first time and try to code. And sometimes it's something that I like practice the day before and then I'm recoding again. Usually it's this, which is like, I kind of understand how this works. I watched this video a couple times. This seems very similar to other things that I programmed. How hard could it be? Famous last words. But I'm about to attempt this for the first time. I have never tried to program this particular visualization. I'm definitely going to need the whiteboard camera. So should I just say Valentine's Day? There's nothing wrong with saying Valentine's Day. I'm going to draw a nice heart here. I'm going to attempt to draw the P3 logo, which kind of looks like a 1, and then it has kind of like a 3, like that. Am I really like live on YouTube drawing a heart and like my own very poorly drawn version of the processing logo? Apparently I am. Okay. Here we go. So let's cycle the camera and let's get started. Actually, I think what I'll do is I'll start with this. And what's... Oh, interesting. This is kind of envelope of a pencil of lines. So this is basically, yeah, this is basically the same thing. Okay. Okay. Oh, whoops, sorry you can't see me. All right, I'm going to start with this on my screen. All right. Here we go. Valentine's Day with processing. Don't make me get out my ukulele. Behave, chat. Don't make me get out my ukulele. Do I have a love song here? I have the lullaby. That's not really a love song. This is kind of lovey-dovey. All right, maybe we won't do any music. We'll add some very impressive music in post. All right, here we go. Hello, happy Valentine's Day from the coding journey. I'm going to say it once. I can be serious for a moment. Hello. There's something in my heart that I love. And here on this day, February 13th, although you might be watching this on February 14th, or some other day in the future, I want to express my love for processing. Processing, a programming language and environment that started in 2001. created by Casey Reese and Ben Fry. Please read all about the history of processing and the Processing Foundation's work right now, processingfoundation.org, and I forgot to blow my train whistle. At least there's no timer, writes Nate the Ace. Let's move this along, people. Hello, I'm here. It's February 13th. I am feeling the love. I would like to express my love for processing, my first programming love, my one true love, processing. And I would express it by creating this. This is a famous shape in mathematics called the cardioid. If I'm pronouncing that correctly, cardioid like heart. It's kind of like a heart. And today, there might be some other videos after this one where I make all sorts of kind of heart patterns, but I just want to make this pattern. Now, if you want to learn more about this shape and where it appears in mathematics, I want to point out to you this wonderful YouTube channel called Mathologer. Mathologer has a video called Times Tables, Mandelbrot, and the heart of mathematics. And my heart is with mathematics and processing and code and all that sort of stuff. Now, I should also point out that rendering and animation of these times tables in processing has been done before, and most notably by Simon Tiger. And one of the things I love about processing this year is there's been this worldwide set at Processing Community Days. Recently in Amsterdam, Simon presented his work on creating this very large poster about the times tables at Processing Community Day Amsterdam. I was just at Processing Community Day New York over the weekend, and my heart is definitely full of love and wonder with all the things people are doing with processing. So this video is dedicated to all of the people who are working on processing and P5JS and fellowships and everything. I love you all. Now everything's going to go wrong because I'm going to start coding. So this shape, you can find it in looking at the ways light reflects around a circle. I mentioned the Mandelbrot set. You can see it right here, as in this bulb of the sort of first bulb of the Mandelbrot fractal set is a cardioid shape. And it's kind of amazing that it appears in this context of timetables. So, and then I think we're gonna, if you watch the end of the Mathologer video, there's this animation at the end, and I was just like, whoa, that looks so cool. And I kind of want to show it to you now, but I'm just gonna program it, and hopefully it'll be at the end of this video, because somehow I'll program it. So let me talk about how this works. Okay, so happy February 13th, everybody. I love processing. Okay, now, let's say, and this is good timing because in my course at NYU this week, just today, yesterday we were talking about polar coordinates, and I'm going to need to make heavy use of polar coordinates for this particular visualization. So we're going to start with a circle. And we are going to divide this circle equally into parts, basically, almost like a pie chart. But the way I'm going to represent that is just by equally spacing out a set of dots. So I think in the Mathologer video, he starts with 10. That seems like a good number. So, and it probably makes sense for me to start over here. 0, 1, 2, wait a second. I think this is going to work if I get to 3 over here, right? 3, 4, 5, 6, oh wait, 7, 8. Oh, we have our first fail. Record scratch. Glad you could edit this part out. Just ignore me. I'm over here looking at something.
And then we label.
Yeah. Okay. Oh, that makes. Oh, yes. 1, 2, 1, 2, 3, 4. Ah. Okay. 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 Let's try that again. I have 1. I have 2. Now I need 8 more. So I need 4 along the top and 4 along the bottom. This is for me to get 10. So 1, 2, 3. No, that's 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I did an okay job there. So this is my circle. Whoa! Oh my God, I just bumped my head on the ukulele. This really shouldn't be here. Boy, interesting. There's going to be some interesting editing in this. I'm okay, everybody. Don't worry. It sounded worse. I mean, if anything, my glasses might be broken. I didn't actually hit my head, I hit the glasses. Okay. All right, I have my circle with the evenly spaced out dots. So now let me number them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want to do times tables, meaning I want to multiply each one of these numbers by 2, and whatever number I get, then I want to connect it to that. So 2 times 0 is what? 0. So that's just here. 1 times 2 is what? 2. So that connects here. 2 times 2 is what? It's 4. 3 goes to 6. 4 goes to, well, shoot. I'm going to have an easier time programming this than drawing it, that's for sure. 4 goes to 8. 5 goes to 10. There's no 10. Well, we wrap around. We use the modulo operator. So we use the remainder, basically, if we keep counting, like this would be 9, 10, 11, 12. So 5 goes to 10, 6 goes to 12, 7 goes to 14, and 8 goes to 16, 9 goes to 18, et cetera, et cetera, et cetera. Yes. So you can see here that this shape is sort of starting to emerge. I did a terrible job of drawing this. I feel like there's a mistake somewhere, but whatever. Close enough, you get the idea. So let's first start by just creating exactly this. All right. Oh, look, it's the number's perfectly spaced out. No, hold on. Matthew, let's edit it to, let me close these other things out. Just because I don't need them open. I don't need this. Let's save this on the desktop as times tables. Let me just add, whoops. Oh, I don't want the debugger on. Let me add void setup, void draw. Let me say size is 6. Let's make it a square, right? 640. 640. Actually, hold on. Let's just see what that looks like. That's pretty good. Wasn't there? Oh my God! I'm not on the right camera. Sorry, everybody. It used to be. I swear, in an old version of processing, wherever I would leave the window, it would kind of remember it, and then when I would run it again, it would end up there. It just doesn't do that anymore. Which really makes me crazy. There's probably a way I could modify. Like, I think I can do like. I don't want to get lost in this, but just give me a second. Just curious. No, it doesn't work anymore. I'll have to investigate that. Ben Fry! Okay. All right. All right, so let me start writing some code. Circle. Okay, so now what I need is I need a number of points. So let me call this like, this is the, what is this? The scale, the divisor, I don't know what to call this. Total points. Just call it total. All right, so and I'm going to make it a float. Let's keep it as an integer for right now. I'm going to change it to a float in a little bit. You'll see why. So now I'm going to, I need to do a loop and draw all those points. I want the center of my visualization. I want everything to be, I want everything to be oriented around the center. So I'm going to translate to the center, width divided by 2, height divided by 2. And then this is where that polar coordinate thing comes in. I need to figure out, the way I'm going to find all those points is, right, there are how many slices of pie here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, how convenient. So each one of these angles is 2 pi divided by 10. So that's how much I need to, that's where each one of these points goes. So I'm going to say a delta, the sort of like delta angle, I'll just call it delta, equals 2 pi divided by total. And then another way I could do is I could just use map. So I could say angle equals map I, which goes between 0 and total to between 0 and 2 pi. That might be an easier way. Then I don't actually need this delta. And then I need a radius, so which is basically, I need to know, like, well, what is the radius of this circle that I'm visualizing? And so for that, let's just make the radius the width of the window divided by 2. So let's call that r, which is the width of the window divided by 2. And then I want to say x equals r times cosine of the angle, y equals r times sine of the angle. And I will refer you to my video about polar coordinates to understand these particular formula. Pause for a second. I see that there's some super chats flying by. Thank you so much. When I finish this coding challenge, I will thank you more properly. Thank you. Okay. All right, so, and then the next thing I just want to do is draw a point. So I'm going to say, I'm going to make an ellipse, fill 255, ellipse at x, y, and thank you, Ben Fry. I'm going to call this circle. There's a circle function now, 16. Oh, I love using these. Okay, so let's see, what do I get? There we go, look. You can see there's my 10 dots around the circle. Now I probably want to be able to see that circle. That would be nice too. So let me say stroke 255, no fill, ellipse, and this, the translate needs to come before drawing this. I just want to draw, no, it's a circle, at 0, 0, r times 2, right? Because the circle function expects the diameter, which is the radius times 2. So now we can see, there we go. Oh, mwah! I have my circle with all my points. Now I need to do my math thing. All right, so I'm going to have a value. I'm going to call this n. So n is going to be what is the times amount that I'm going to multiply each number by. So there's there's a lot of different parameters in the system, and you can play with them to create all sorts of different kinds of patterns. Hopefully we'll see some of those by the time I get to the end. But right now I'm going to make this a 2 times table to try to get that heart, that cardioid. So I'm going to call that, maybe I should call that factor. Let's call that factor. I'm going to put that up here, int factor equals 2. And I'm sure there's a nice way I could do all this together, but I'm going to do this as a separate loop. So now I'm going to do this again. I mean, obviously I'm just I will refactor this later, as I like to say. But what I want to do is I want to say A is I. Like I want to go from point A to point B, which is I times factor. Those are essentially my indices of like where I'm connecting the lines. So 0 goes from 0, 1 goes to 2, 2 goes to 4. And then I need a function. This could be really useful for me to write a function that returns a p-vector, giving me a p-vector for any given index. So get vector for any given index. And then, so basically I can say the angle is map that index, which goes between 0 and total, between 0 and 2 pi. And then the vector equals a new p-vector at, and this should be a global variable, r. I cannot set the width up here because it doesn't know what the width is. So I'm going to make this r here, and then I'm going to say r equals width divided by 2. I could make that an argument to this function, but I'm just going to keep that as a global variable. Make a new p-vector r times cosine. Oh, actually, p-vector class has something in it. P-vector from angle, that'll make the vector pointing in that direction, and then I just want to multiply it by the r to set it to be that. And then, right, so I'm using some vector stuff here, which I realize is now maybe a little bit beyond the scope of if you were coming to this video just without knowledge of how the p-vector class works in processing, or in P5, which is a P5 vector. It's just an object that has an x and a y. So it's a nice way for me to store the x and the y together, and I can make the x and y components from an angle, and then I can scale that by multiplying it by some radius. So it's really got that sort of polar coordinate thing built into it. So I'm going to multiply it by r and say return r. And then actually, since I'm here refactoring this, I can say right here, p vector v equals, what did I call that function? Get vector based on I, and then I should be able to say v dot x, v dot y. So I basically just took that code and put it into a function because I'm probably going to need to do this quite a bit. And I don't want to return r, I want to return v. Oh, this is, I'm liking what I'm doing so far. I think this might actually work. Okay, so now I want to say get vector for I, and then get vector for I times factor. But guess what? It's not just I times factor, right? So first of all, why? Oh, this should be a p vector. This should be a p vector. So it's not just I times factor, although I guess I could rewrite this function. It depends on where I want to put this. Actually, I'm going to put it here. So I need somewhere to deal with the fact that when I do 6 times 2, I get 12, but I really just want 2, because 12 divided by 10 is 1 remainder 2, so 12 modulo 10 is 2. The modulo operator, which I have a video, thank you Golan Levin, about modulo, is also linked now up there somewhere in a corner of this screen. Okay. So now, right here, I could just add that here, modulo total. All right, so I don't think I actually drew those lines, but if this is still working, that's there. Now I should be able to say line a dot x, a dot y, b dot x, b dot y. There we go. Oh, it's backwards. Why is that? I mean, it's not backwards. Oh, because I started over there. Interesting. So a couple things I could do. I could just call like the scale function to flip it the other way. I mean, what's backwards, what's forwards? Who knows? I'm just saying, in terms of watching that Mythologer video, it was oriented the other direction. I also feel like R needs to be a little bit smaller than the actual size of the window. So let's make R equal, like, let's give it a little bit of buffer, like 16 pixels. That's a little bit nicer to see. Again, my visual talent skills are so non-existent, and I know people are watching this who are designers and with artistic vision, and you will make something beautiful out of this, and I can't wait to see. I saw a chat message go by, which is really quite smart, which is that I could just here, if this is the angle, right? This is the angle. All I have to do is just, if I wanted to start on the other side, I could just add pi, being 180 degrees. So if I'm starting with the angle here, which if this is 0, if I always just add pi, I'll get here. If I'm here, I'll get there, that type of thing. And when I say pi, I mean the number pi, not delicious blueberry, vegan blueberry pie. Okay. Lost time out for a second. I feel like I have to blow my nose. Where are my tissues? It's dripping. Okay. All right, let's give this a try. Oh, it looks right. Okay, now we're getting somewhere. So the Mythologer uses the number 200. I'm just gonna, let's go to 20 and see what we get. Ooh, that's kind of interesting. Let's go to 200. Wow, there we go. Mwah, mwah. There is the cardioid. Ooh, that is like beautiful just on its own. And by the way, what's interesting about this is very similar, if not precisely the pattern you would see if there were a light source here and it reflected and bounced around this particular circle. So, okay. All right. Oh, it needs to be red. It needs to be oriented the other way. It needs to have like an arrow through it. It needs to have like a little baby Cupid flying by. Lots of things. All right. But I want to make this animation. So there's a bunch of different things we could do. For example, this could be a variable. So let's just look at that really briefly just to see. I'm going to say float. I'm going to make it a variable here equals 200. Or I'm going to say, sorry, int total equals map. Mouse x, I'm going to take the map function, mouse x goes between 0 and width, and I'm going to map that between 0 and 200, and then I'm going to convert that to an integer. So now so then, good point, let's have this take a total, and then the get vector function should have the total passed in. Maybe there's a different way of doing it, but now we can see basically based on the number of circles, we can see as I move the mouse left and right that increasing. So that's one way I could animate this. I think it's probably us to decide like a different way of animating this, which I will get to in a second, I think is possibly more interesting, and it's varying the factor. Like, what happens if this is a 3 times table? By the way, we could just try that right now. So let me make this back to 200. And let's make the factor 3. Look at that. Interesting. Now, by the way, I shouldn't do this, but I'm going to try this. Let me go to the Mandelbrot code. Okay? Now, the Mandelbrot code creates this pattern. Why? It creates this pattern because of this formula. Z equals Z squared plus C. Why is there an M there in the comments? What if I change this to a 3? That would mean, that's going to change. I can't do that so easily without it. I need a complex number library. Oh, this is. I thought like, I could just, in my head, I was like, I could just do this. That's interesting. Okay, I'll come back to that later. Maybe we should. This is the math for squaring the complex number, and I would have to like rewrite this entirely. Okay, so this won't make it. Nephroid, thank you. This won't make it in the final edit for this. I'm looking at the chat. Right, okay. All right. So, nice idea, but I'll come back to it. All right. Breaking news. I'm being told from the chat that this shape is called a nephroid. So this is a nephroid, and if I would go to, say, factor 4, look what I've got now. So this, and interestingly enough, we could actually make these floating point numbers. Let's just see if I have to change anything in my code if I do that. I'm going to, I think. But let's see. So I'm going to do this. All right, so immediately we're stuck here like, these are no longer integers. So what if I make this a float and this a float? Let's have everything be floats. There we go, that worked. Let's be sure about this, right? So that was factor 3. Let's try factor 2.5. Yeah, this is looking like it should look. So this is actually doing the same exact math, but it's allowing for the spaces in between. So what if I have 2.2? That should connect to 4.4. And we can do modulo also because 7.1 would connect to 14.1 modulo 10 would still be, 7.1 would connect to 14.2, modulo 10 would still be 4.2. So this works with floating points. And now we can create that animation. And so what I'm going to do is I'm going to make this the global variable, factor. I'm going to start it at 0. And then I'm just going to slowly over time say factor plus equals 0.01. Interesting. Oh, there's the cardioid. There's the nephroid. Isn't that lovely and beautiful and amazing? I just love this. Now, think of the possibilities. I have done the most basic thing to just create this animation. And at some point, it's like really crazy stuff that's going to start to happen. But there's so many other parameters. There's ways you could think about color here. I'm going to make a JavaScript version of this that will run in the browser that I will publish that you can look at, which is basically exactly the same code. I could look at this forever. I hope you enjoyed this dedication, long distance dedication to my true love, the heart of mathematics and processing. Mwah. Wait. I don't want to go just yet. I love how it just keeps going. It like never stops. So what I want to do actually, before I leave, besides make it all rainbow colored, is I want to just show you, this is a nice way to increase the factor, but I'm going to make another video that's about making a perfect GIF loop And I think this is an opportunity for us to make a perfect GIF loop. So where would be a part that matches up? So one thing I could do with this factor, So one thing I could do with this factor is say like map it to a sine wave. So for example, what if I have a variable called t, which is going to be like, I'm going to keep track of time. And I also have a variable called like dt, which is like my time step. And maybe I'll just go up by 0.1. And so what I want to do is factor equals map the sine of t, which comes out to -1 and 1 between 0 and 200. Yeah, we could go all the way up to 200. I don't know how high we should go there, but let's try it up to 200, and then t plus equals 0.1. So this would now have the factor value not just increase over time, but smoothly oscillate with like an easing function, a sine easing function. There's lots of other easing functions you can use, all the way up to 200 and all the way back down to 0, which would be a perfect loop. So let's try that. I think that's a little bit too fast. Well, maybe 200 was too high. Let's have it just go up to 50. Still, whoa, okay, so I have to figure out what makes sense here. 5? There we go. So you can see that hit 5, and now it's coming all the way back down to 0 and back up to 5. So I don't know that I've hit on this exactly right. Let's make this go up to 20. Let's have t go up even slower. Why does it starting? Oh, because sine of 0 is 0. Opposite over adjacent. Oh, no. It starts at 0. So, ooh, weird. I want it to start at 0. So let's make this, what happens if I give it a negative number? I'm just curious. That was interesting. So I'm just seeing what's happening. It's going all the way up to 20. Let me just actually have it go to 2. Oh, wait. Yeah. Interesting. That's weird what it does with the negatives. So I don't want the negatives. So this is the simplest. Hopefully a lot of stuff just got cut out there. I was confused. The issue was sine goes between -1 and 1. All I need to do is have time start at like Hopefully there was a weird little edit point there. What it wasn't doing what I wanted to do, because I wanted to start with times table 0, but sine of 0, while it is 0, is then, if I'm mapping between the range -1 and 1, it starts at 1. So I could just change this to cosine, because that would start at -1, or it actually starts at. Sorry. Yeah. No, it starts at 2. Wait a second. Sine of what is -1? I should know this, right? Let me just show you how I figured this out. It's pi over 2, or like 3, right? Oh, why did this not come on? Because so one of the things I love about thinking about sine is like, why is sine of the angle? Why is sine of 0 degrees 0? Well, if this is the angle, sine is opposite over adjacent. Or I could call this the y and this the hypotenuse or something. So y divided by h. And imagine as this angle gets smaller and smaller and smaller and smaller and smaller, like this. Eventually, if the angle is 0, the length of this side of the right triangle, it's not a right triangle anymore, is 0. So even though the hypotenuse is whatever it is, 0 divided by that, so sine of 0 is 0. Now, sine of what is 1? Well, if the angle were 90 degrees, right, if the angle were 90 degrees, then that side of that right triangle, basically, which isn't a right triangle anymore, would be equal to the hypotenuse, so it's 1. So 90 degrees is 1, so it must be like negative 90 would be negative 1, right? So if I started at, like, if I just say print line sine of negative pi divided by 2, negative 1, right? So that's where I want to start. So I'm gonna make this have some continuity here. Oh wait, did it just work by accident? No, I don't know what's going on anymore. Why did it start at 0? That was weird. Use trig circle. Yes, a unit trig circle would be better. I always think in weird ways, though. Trig circle would totally be better. Oh, because they had 1, 0, and 2. So weird. Let me just. I've ruined this video. It's going so well. This is what I want. Oh, that's. Oh, because 0, everything connects to 0. I actually want it to start at 1. Because I want it to be at. It doesn't actually matter. I was thinking that 0 makes everything, you see nothing, but I'm totally wrong about that. When the factor is 0, everything connects back to 0. When the factor is 1, you see nothing. So in a way, I actually want to start at 1, which is, no applause, please. I want to start at 1, which is pi divided by 2, but how come that, oh, that's starting at 2, so negative 1, oh, it's actually perfect. I had it right all along. It just was like such a high number. Whatever. I shouldn't have gone with this. Let me just go back. I'm going to like ignore that. I thought this was like an interesting idea, I think. It's just, it happened so fast at the beginning. So in a way I wanted to, this is not the sort of like, yeah, no, whoa, weird. When because it starts at 5. When it's 0 to 2, it's always in the middle. So I want t actually to very specifically, I see. I get it now. I always want, if I always want it to start at 1, I always want to start it at whatever this number is, divided by 2. I always want it to be 10% of the, in this case, so if it were 20, I would need this to start at 2. This is so silly what I'm doing. I don't like, right now I'm mostly just, all right, so let me think about this more for a second. So this could actually, I could actually have this be a number. So I always want the starting point to be whatever, so I could just do arc sine, right? So for example, if I were to say, let me just figure this out for a second. If this were factor, max factor is 20, right? Then what I want is, and this would be max factor. This is no longer a global variable. T should start at arc sine of max factor divided by 2, right? trying to think about this. Sine of t 0 to 1, 1 to 20. Oh, that's a smart way of doing it. Yes, it would be so much easier if I just multiplied max factor by sine. or if I add 1. Cosine of t plus 1. That's a good solution. You know, I was doing so well, and then I went off on too many tangents. That's an interesting idea. Let's try that. No, I'm map. Wait, hold on. I can work this out. So many ways to do it. On 0 to 2 and 1 to any. No, that's not going to work. Use frame.setLocation in the draw function. That's interesting. Hold on. I want to make this start always at wherever it's going up to. Okay. This is so silly. Let me do it this way. Sine, because this will be an easier way to think of it. Factor equals sine of t plus 1 times max factor. And then, well, this is the same thing I had before. But if I'm just getting rid of the map function to think this through. Oh, we could do from 0. That's actually a really good idea. Right? Because the map function doesn't care. If I say map sine of t with a range between 0 and 1, and I always want to start it, whenever it's 0, I want it to be 1, max factor. Yeah, there we go. Yeah, that's what I want. Yeah, okay. I don't know why I couldn't think of that. So what did I have before? This? Okay. Sorry for that digression, everybody. Lost my mind there for a minute. It's very stressful to do this in front of a live audience. All right, I'm back. I went off on down a whole rabbit hole of like figuring out something which is actually quite simple, which is that I was wondering why it wasn't starting. What I wanted it to do, I wanted to start like this. If I put this at 2, I want it to start where the factor is 1. I want the factor to be 1 because I want it to sort of start in this loop with it always at with you just seeing the outer circle, and if everything is multiplied by itself, then 0 connects 0, 0, 1, we have no lines. But if I increase, and this works if I'm going between 0 and 2, because sine of 0 is 0, and in this mapping function I end up with 1. But if I were to change this to 0 to 3, then it's starting somewhere else. So that's not what I want. And actually, a trick that I could do with the map function is I could just sort of, even though the range is really -1 to 1, it's going to figure out what to do even with something negative. So I can actually tell it the range is from 0 to 1, and then, but whenever sine of t is 0, it should always equal 1, and then go up to like 20. That should work. Although it's really fast. This is just like way too fast. Still pretty fast, but that's because I'm going so high. Let's just go to 5. I just want to see like a smoother animation. There we go. This is what I'm looking for. So you can see it started at 0, and it's sort of like coming up to 4 of those little bulbs, and then back down to 0, and then back up. So, oh, t is supposed to increase by dt. Ah, whoops. Yeah, I don't know why I made this dt variable and then didn't use it. Oh, there we go. I was also missing dt that whole time. So I could control it, and we could probably make this 20 now. Yeah, and we could sort of see, there we go. This is a little bit better. So I just wanted to see it sort of like smoothly breathing animation that loops. So it's going to go all the way up and back down. I don't know. This video was going so well at the beginning and it became a bit of a mess here at the end, but I am really excited to see what kinds of things do you create from this, the heart of mathematics, the cardioid shape. Thank you for watching, and I'll see you in a future coding challenge. Goodbye. So it really slows down as it gets up there. Isn't it, in fact, sweeping -5 to 5? Ah! I think you're right. All right, let's understand how this works. I should really do this in like, right? If I get the value 1, if I get the value 0, this should print, I should see a 1. That's exactly what I want. If I see the value 1, I should see a 5. What if I do -1? -3. Yeah. So this isn't really right. The problem is, so there's a nicer way to do this, which is I could just say, right, I could have t start at -pi divided by 2 and map sine of t Yeah, that's what I want. What's wrong with me? This is what I want. Or I could have used cosine, because cosine will start at 0. I don't need to go back down to 0. Cosine of 0 is, no, cosine of 0 is not -1, so yeah, okay. Let me redo that again. Ah! This is even like simpler than what I had. Sorry, Mattia. Negative cosine. Oh, you smart people in the audience. I'm going to do it. Cosine starts at 1. I know. So I could map it from 1 to -1. There's so many ways. There's like 100,000 different ways I could do it. It's actually not that complicated. I've just lost in my own thoughts here, which is a thing that seems to happen a lot. Okay. All right, there's a weird edit point. This is actually working the way I want it to work, but it's not starting at the right spot. Like, let me just run this again. It kind of like starts in the middle, and I want it to start where the factor is 1, because I want all the points to connect to themselves, which is when I don't see anything, because I don't see any lines, because every line is drawn from the point to the point. So actually, there's a really simple way to deal with this, which is that sine, t starts at 0, and sine of 0 is 0, so like the factor is actually starting at 5 here, because if I'm in the middle of the range, then I'm just going to change this range. I don't care about the range between 0 and 1, actually, for the purposes of the animation. So I'm going to start the range at 1, and then sine of what is -1? It is pi divided by 2. So I can just start at -pi divided by 2, which will mean sine of 0 will be at -1, and then you should see this. There we go. So it starts, I want this to loop all the way up to this number of however I'm going up to 10, and then all the way back down to 0. So now I have some stuff that I could play with in terms of like, oh, I could have this go up to 50. I could change dt to be like twice as fast. And I don't know if this is, it's way too fast probably to like get the effect of the animation. Yikes! But you get the idea. Sorry for how crazy that looked. Let's make this do this, like even slower. Come on, see it start to form. So this will now be a nice slow animation all the way up until 50. I'll take this out. I am excited to see what you make out of this. What happens when you think about the geometry in a different way? You think about rendering this in a different way. You think about color. You think about multiple dimensions. You think about different styles of animation. What if you were actually draw all the lines as they, I don't know, there's so many possibilities here. I hope you explore this and make your own version of the cardioid to express your love for somebody on this day or every day of the year. Thanks very much, and I will see you in a future coding challenge. Yeah, 3 pi divided by 2 equals -1, but it's the same thing. It can be negative, right? All right, now with colors. I'm going to let everybody make their own version of this. Let me just quickly put this in the web editor so we have it. But I actually kind of, this didn't the looping of this didn't work the way I kind of imagined it would. So I think I might actually prefer to just leave it at, I think this actually was a nicer animation, to be perfectly honest. Hey, Espen Larsen joined as a new member. Espen Larsen is the creator, the singer, the composer of No, I'm not leaving. That was just the n sine squared from 0 to pi. That's interesting. All right. Sorry, this is way too much fun to watch. I feel like I want to do this. Actually, I want to do this. Oh, it's slow. Interesting. Why is it slow? Sorry, I can't help myself. Let me just play with this for a little bit, just a little bit longer before I go into the next coding challenge. I feel like these circles are, which ones are unnecessary? Wow. Will I get just as much value out of fewer lines? No, let's I just want to give it a little something. And what happens if I do this with hardware acceleration? There we go. All right, let's take a little break and let this play. I'll do some thumbnails. Okay. So let me do some thank yous. Here, where is this? Thank you to Israel Arahuho. Sorry. Thanks for your passion. I learned a lot with you. Thank you to Otakus. Thank you. Welcome to new member Ecker Technologies and new member Espen Larsen.
I will refactor this later, you know. I will refactor this later. I will refactor this later, you know. I will refactor this later.
Let me just say, membership-wise, there is a join button on YouTube. I also have a Patreon. I'm constantly thinking about whether I'm going to keep the Patreon or not. But I don't have a lot of benefits for people who join as members. I do mail you a sticker, or not a sticker, a bunch of Coding Train stickers. You can see some of them here. And then I sometimes do live streams where I'm trying to test out an idea or fix something that will just be for members only. That's pretty rare, wouldn't count on that. And then we have a Slack channel. So again, I should mention that if you have recently joined as a YouTube member but you don't have a Slack invite, check the community tab. And it's probably maybe I should post a new one. The only way I can get you a Slack invite is through a Google form. I haven't figured out another way to do it. So to Ecker Technologies and Espen Sande Larsen, hopefully I can get you your Slack invite soon. Okay. The song, by the way, is Manfred writes, you've got to make this song longer. There actually is a full version of the song on Spotify that you can find. But and I will ship the stickers anywhere internationally. It's very inexpensive to send something in the mail. I mean, it just costs $1 or $2, so I'm very happy to send you the stickers wherever you are in the world. The thing that I have a problem with is I don't get to it very quickly. And so sometimes you have to bug me a little bit about that, and I apologize for that. You shouldn't have to, but yeah. So okay. It's just, by the way, what's interesting is it's just still going. I should really put what the factor number is. This would be interesting too. Let's just do this for a second. Text factor number format. Number format, by the way, is a function in processing that will control the number of decimal places you show. And so we can go like this. Whoops. Oh, text is a little weird in P2D. Will this work? Oh, whoops. Oh, I forgot because I am... So now we should see that's the factor up in the top left. So we'll see, that's kind of interesting to see what number it is by the time it gets to different patterns. So you can see that's 5. You'll see the number of bulbs is 1 less than number 6. All right, so what else am I going to do today? It is noon. I've got another hour or so in me here. I want to do the, I definitely want to do, the next thing I want to do is the GIF loop thing. Okay, so I have to think about this. I just like letting this run. Can I let it run in the background while I do other stuff? Yes. So let's look for, hold on, I've got to find some messages sent to me from Golan Levin. Is this it here? No. Oh, it's because it's not with the G. So this is good, and this is good. So this. Okay, I'm looking for this. I am also looking for Saskia Freak. Where's the best way? Is it Tumblr? Yeah. Okay, and so let's look at this. No. Okay. I have this. And then there was something else that I'm looking for. GIF loop gallery. Okay. Interactivity and computation. GIF loop gallery. I think this is what I'm looking for. Okay. These are awesome. Oh, I love this. That's really great. Love all these. Okay. Okay, so I think I am ready for the next coding challenge. Where are we now? We're up at factor equals 75. Simon, in Simon's poster, I wonder how many go up to max factor, then reverse the sign of dt, and you get back to 0, and then reverse again. Yeah. Whoa. It's interesting how it sort of comes back to what it was, of course, at the beginning. Okay. All right. Yeah, a slider would certainly be an option. Okay. So let me I just want to put this back. Yeah. I'm just getting the code into a place where I can release it. I think this will be fine. Yeah. All right, great. Okay. So okay. Let me just look at let's look at Golan's code for a second. So I want to make like a simpler version of it, but it's super good to see. So let's look at this one. So if I run this, all right, so this is what it's doing. So the technique here is to have a counter that basically goes from 0 to 1. That's like a percentage complete of the loop, it looks like. And there's you specify like the total number of frames. So like if I change that to 500, it's really the same thing, but it's just running slower because there's like more frames. If I change this to 50, we'd see it like this. Okay. And then this will start recording it. So if you're recording it, you always compute a percentage, and then you call like a render function with that percent. That's pretty interesting. And then it takes a percent between 0 and 1, and then there are two different graphical techniques. For example, like this spinning thing, and it's percent times 2 pi. That makes sense. And then transformations, percent times 2 pi times negative 0.25, interesting. Linearly moving, percent plus 0.5 modulus 1. Map percent 0 to 1. Okay, so that's like linear. Sigmoidally moving pink square. Function double exponential sigmoid. Oh, fascinating. Oh, I see. There's all these different easing functions. How much do I want to get into all this? Traveling sine wave, percent. That's super interesting. Okay. Okay. All right, so easing functions. Yeah. So like different easing functions you could use. And okay. Yeah. Got it. Okay. Okay. I think I have use cosine square. What's that? Okay. So I think I'm ready to give this a start. All right, let's get this going. Okay, hold on. Let me erase this. I really want to adjust my Mandelbrot code to being able to do the complex numbers to like the third power, the fourth power. That should be an interesting thing to do. So maybe I'll get to that at some point. Let me just check the chat here. Okay. Oh my goodness, I forgot to record this to disk. It's fine, we'll have to get it down from YouTube, but I'm gonna need to do some green screen thumbnail shots later. Sorry, Matthew, shoot. I don't know, here's a hint for you. What's this? I don't know what's going on here. This is something happening in the chat that's not, The quality on this live stream was hopefully okay, because I'm going to have to, when I edit this together, when Mathieu edits it together, it's going to have to be the YouTube archive that gets edited, because I forgot to hit record to disk. Use atan2 to get angle and modulus to get length. Maybe the chat is discussing something that has nothing to do with me right now. I need to move along. Everyone's saying lag. Was it lagging before? Hopefully it'll be fine. Hopefully it will be fine. All right. Anyway, I'm recording this to disk now, so everything else from now will be okay. What I want to know is It was not lagging during the challenge. Okay, great. Okay, great. All right, well, we can always fix some things in post by like overlaying the visuals if we have to. But I'm going to move on. All right. Okay, I get that it's lagging. Let me just check the, bad. So I don't know, it says the stream status is currently bad. I don't know what to do about that. All right. All right. Here we go. Hello, I am here today to do a coding Oh my God. I think I have to minimize the chat. Yeah, okay. Should I add slow mode? I don't know. Hello, I am here today to make a coding challenge about making a perfect, well, whatever I make won't be perfect, but you might make something perfect, GIF loop. So what is a GIF loop? Why am I talking about GIF loops? So one way that artists who work with computational media and computer graphics are distributing their work and expressing themselves is through posting GIFs to various different online platforms. An artist I would like to highlight is Saskia Freak, who has been making daily animated artworks for quite a long time. In fact, maybe there have been at least 1,500 of them, which is mind-blowing. And you can see a whole variety of them here on her Tumblr. There's some other, I think she wrote a Medium article about this process. They're amazing. A very famous GIF artist that I have referenced in previous videos. In fact, I did a whole coding challenge trying to recreate his cube wave is Bees and Bombs. So Bees and Bombs creates looping GIFs through algorithms and math and graphics in all sorts of astonishing, mind-blowing ways. So I encourage you to check out Bees and Bombs. Also Tumblr to see all of the kinds of GIFs that he has created. Golan Levin at Carnegie Mellon University, a professor at Carnegie Mellon University, gives an assignment every semester in his course, Interactivity and Computation, to create a GIF gallery. And so to create a GIF. And this is a gallery of GIFs that students made in his course just this past fall. And Golan has a lecture about loops throughout the history of art. You know, it's very easy to think as we work on programming the computer and make algorithms visual and happen in JavaScript in the browser with your OpenGL shaders, WebGL magic, that this is the first time any of this has happened. But this kind of work has been happening for years and years and predates the dawn of computers themselves. So this is a wonderful set of historical references to different kinds of loops that people have been making. And of course, here's the iconic Muybridge galloping horse that you can see here. So I encourage you to check out all of these resources, read about loops. And in fact, you don't even need to watch this video. You can go right here to Golan's loop templates, which has templates for processing Java, P5.js, JavaScript, and Python processing as well. So what I'm going to do, though, in this video is I'm going to make my own. I'm not worrying about making something artistic or innovative or beautiful. I'm just going to try to show the process from start to finish of writing code and processing, rendering it out to files, and then packaging that up as a GIF that you could post. I'm also going to come back and do a follow-up video. There's a new P5 JavaScript GIF library that some students of mine worked on last semester in a course about open source. And so I will come back and show that in a future video as well. So let's get started. So what is the driving principle of making a loop? So if you look at Golan's code examples, the core idea is to have first a total number of frames. So a GIF, an animation, is just rendering a whole bunch of images in sequence at some frame rate for your eye to see, and it appears like animation. And if whatever it is in the last frame, or really what would be the last frame, the sort of like frame before the last frame, matches up exactly with the first one, then you have a loop. So in other words, if I'm drawing a circle here, and then it goes to here, and then it goes to here. Oh, I don't need that many frames. And then it goes to here, and then maybe it disappears. I have a blank frame. Then, in theory, the next frame I want to see would be it entering the screen again, but instead I go back and show the first one. So this will look like it's a loop that's going on forever, whereas in reality, it's just starting at the beginning, and the last frame matches that. And so as it goes back to the beginning, it appears infinite. So this is the idea. So a couple things we need to do. We need to keep track of like what is the total frames we want. So we're going to need some sort of variable like total frames. Like in this case, I want to have 1, 2, 3, 4, 5, and I'm really going to use the number 6 because I'm going to render. This is 0, 0, 1, 2, 3, 4, 5. Wait, hold on. Let me think about this. If I don't want to render out the last frame, but the idea has 6. Anyway, everything's going to be okay. Just take a break, take a deep breath. Am I supposed to look at the chat now? And probably everybody's saying, why doesn't he look at the chat? I can tell that's what's in the chat. I don't even have to look at the chat to know everybody in the chat is saying, why doesn't he look at the chat? I'm going to go look at the chat. Oh no. I knew it. I knew it. I knew what this would happen. I knew it. I'm going to have to pull this car over. I'm pulling this car over. GIF is spelled with a G. Some people like to say G, and some people like to say J. But I like to say G, but I don't mind it if people say J, because we can all pronounce the word together, and we can be friends together too. GIF is spelled G-I-F. Did I just say GIF? GIF. GIF. Ah! Where's my pen? Where's my pen? The G is silent. If. I think that's a good way to pronounce it. If. I lost my pen. My marker. And I have to go. I have to go be a human being somewhere else in the world today. How come I lost that marker? I have a sweater. I have like a keyboard. I have, oh, here's a marker. Is this the marker I was using? Maybe. All right, I don't want to get lost in the details of the total here. Let's just say the idea is that the animation itself has 6 frames, 0, 1, 2, 3, 4, 5. That's the frame count. And then I might not include the last frame when I actually stitch it together because the last frame is really back to the first frame again. But the point is I need a total number of frames. I need a total number of frames. And then I also want to have a variable called %. And the idea is that % will always be the current frame count, will be the current frame number divided by the total number of frames. And what you'll see in Golan's example, let's do the same thing, is if we have the ubiquitous processing draw loop, draw is looping over and over, we could actually put our code somewhere else. Like maybe I'll write a function called render, and we would just call that function render, passing in the %. So this is a function that knows how to render some kind of design based on what percentage of the way through the design it is. And as long as the design is thought of in a way where the end matches the beginning, then this is going to work out. And all the other stuff about like saving frames and all that kind of, is it recording, is it not recording, that could be in the draw loop. Okay, this is way too much explanation for something that's in essence like quite a bit more simple. But there's one thing I wanted to say. that I was thinking of. Yeah. All right, there's two more things I want to say about this. One is Golan writes in his instructions to his student, sketch on paper first. So I really recommend you do that. If this is something you want to create, try working this out with crayons, markers, charcoal, pencil. That's a really helpful, going into that sort of like analog drawing process will really help you think through your ideas. Number two is, what are the kinds of algorithms that move a value from one number to another number, and in fact maybe like wrap back around. And there are all sorts of different kinds of ways of doing this. Probably if you've watched any of my videos before, you might be thinking of the sine function. The sine function is an excellent function to use for a GIF loop, because if it the sine function, if I were to graph the sine function, right, where it starts, it repeats. It's a repeating pattern over and over again. You could also use, and then there's a ton of different kinds of easing functions. So there's this lovely website called Easing Functions, easings.net, which is an easings function cheat sheet. And I highly recommend you explore some of these other easing functions to think about how you might move a value through this loop. And if you go to Golan's code, I'll just click on the processing one for a second. You can see, like, even in the code here, there is a this like double exponential sigmoid easing function. So anyway, that's a like exploration you can do separately from this video. Let's just get the basic mechanics working. So for example, I'm going to go back to processing. Actually, let me make a new sketch. Or do I have a sketch already? Whatever. Make a new sketch. I'm going to call it GIF loop. Sometimes I just like start to, am I at 2 hours yet? Once I get to 2 hours, I stop being able. So I like reading the chat sometimes. All right, so I have a blank processing sketch now. And I'm going to go add setup. I'm going to draw. Let's make it a square, like 400 by 400. Let's make the background 0. But no. Let's make another function called render. And this function is going to take a value like %. And what I'm going to do is I'm going to say render %. I'm going to say the % is I'm going to make my own variable called counter divided by the total frames. So this means I need to say, like, okay, well, I want to have 120 total frames in this GIF. I want to have a counter equal to 0. And now here, what I'm going to do, let's just do something like, say, the ellipse. An ellipse is at % times width. This would be a linear function now at height divided by 2, and which is like 20 by 20. So we can see now, if I say counter plus plus, and I'm going to say float counter, let's just see if this works for a second. So this is the idea, that I have a total number of frames. I have a counter that's going to go up, and I really want to, after I want to start the counter at 0 and then count up by 1 after render. And the idea here is that a much more complex, sophisticated design with all sorts of different kinds of easing equations could be in here. But let's just see if this works. I have some brackets out of place. I have some weird extra slash here. So let's see what happens. There we go. So we can see it's moving across. It's almost like the ball is moving because it's being drawn based on a %. Now, how would I determine how I want to render this? So if I'm I'm just going to have mine start recording right when the program starts. So if you look at Golan's example, it's a bit more sophisticated. You press a key, it starts recording. But here what I'm going to do is I'm just going to say, right here, save frame GIF dash ###, which are hash PNG, and I'm gonna make a folder called output. So what this function does is it saves an image to the directory output associated with this processing sketch as a PNG. Those hash symbols or pound symbols indicate to processing that you want the file name to be numbered based on the frame count. I'm going to do this a different way. Oh! Because I want to use my own counter. This is going to use the automatic frame count, which is probably fine. But what I want to do is I'm going to say plus number format counter 4 plus PNG. So I'm going to add the counter number in here manually. I think that's going to be a little better. This number format function says use 4 digits no matter what. I guess I can just use 3 because I know I'm going to I'll have 120 frames, only need 3 .png. And then what I could say is if counter equals total frames, I'm going to just basically say exit here. So I'm going to tell the program to stop. So let's run this. Okay, now let's look. I have a folder called output. I look in there and we can see, there we go. I have all my images. So there are tons of ways now I could take this and stitch it together as a GIF. Let's actually do that really quickly. So for example, I'll pause for a second. Sorry, I'm looking at the chat. Okay, I'm trying to decide if I want to do this. I'm not going to do the stitching now. Okay. So I'll show you how to do the stitching later. In fact, this new P5 library actually will just create the GIF for you. But it's kind of nice to have them as separate images. We do have this question of like, do I have it matching up correctly? Like we should see, the last one should be 119, and it's there. So my algorithm is perhaps like not the best. Like really like this percent times width isn't really like a perfect loop. So that's something I might need to improve. But let's make something that I know will be a perfect loop. So for example, one thing that I could do now is I could say, all right, let's use rotate. So I'm going to say angle equals percent times 2 pi. And I'm going to translate to the center of the window. I'm going to say rect mode center. I'm going to say no fill, stroke weight 2, and then I'm going to say rectangle at 0, rotate by some angle, rectangle, let's use square, square at 0, 0 with a side length of 100. So let's look at this. Ooh, what just happened? No fill, stroke 255. And this should have a fill of 255. So now we can see this is spinning. Now in theory, that's going to match up perfectly because that rotation at 2 pi equals the rotation at 0, and I'm rendering the very last frame right before percent would be 1, in which case it would actually be 2 pi. So this should match up perfectly. Let's now, I'm going to comment this out. Let's do this one more time. Let that spin. Stop. Now let's actually make it a GIF. All right, so I need to look up really quickly. I need to look up really quickly how I would, what's the, let me just look. I think it's on Golan's homework assignment, like some recommended websites, like EasyGIF or something. I guess I could just Google one. I just want to find like a reputable GIF stitching website. GIF. I mean, you could do it in Photoshop, but I don't want to use Photoshop. GIF stip open source GIF. Well, somebody's going to recommend one for me. Oh, posted assignments. Okay, let me look. Probably says it. I'm sorry, I'm looking at a different computer right now. Tips for making GIFs. GIFmaker.me. Let's try GIFmaker.me. Giphy I like, but the Giphy tool just lets you capture it. So let's go to GIFmaker.me. Yeah, let's just do this. Okay. All right, so I'm picking just this website that was recommended on Golan Levin's page, gifmaker.me. You can also make a GIF with Photoshop. There are countless, I'll include some other resources of how you can do it. But what's nice about here is I can click this Upload Images, and I can go to the desktop, to this GIF loop, and, oh, whoops. Hold on, where is this sketch? Oh, I didn't even save it. Oh my God, I'm such a loser. Hold on. Hold on. Let's delete that. And let's go to the desktop. Let's run it. And I can click Upload Images. I can go to the desktop. I can go to my processing sketch called GIF Loop. I can find this output folder, and then I can just do Select All, hit Open, and it is uploading all the images. Oh, I'm pulling my GIF out of the oven. It's ready. Ding! All right. And now you can see, look, I have this control panel, which lets me do stuff and change the animation speed and blah, 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 blah. Create GIF animation? What do I do now? Download the GIF. And then I go here. Let me find it. Oh, it's so slow. It's so slow. So let's, there must be animation speed. Does that make it faster or slower? Hold on, I have to look at this. No? Slower? Oh yeah, oh, I see. So hold on. So we can see the GIF here. It's actually running really, really slow. That's because this animation speed is set at 200 milliseconds in between each frame. So if I change this to 10, maybe even just 2, let's maybe 2, let's make that 5. There's 10. There we go. So we can see that looks good. Now, can you see, is that a perfect loop? Looks like a perfect loop to me. So now I should be able to do create GIF, create GIF, and then hit download the GIF. It already was there. And then if I look at it in Finder, no, what? Let me just, why is this not working? View the GIF. No, it's still so slow. Why? Why am I not able to get that speed? If I refresh this, does it? Let's try that again. Does GIF, hold on. So there's the GIF maker on Giphy, which I use, but I thought, oh, let's do this. Let's do this. It's so much better. Okay. All right, I'm ready to make my GIF now. And so what I'm going to do is I'm going to use, Giphy has a GIF maker here at giphy.com/create/GIF-maker. And I can add multiple images to create a GIF slideshow. Ooh, I'm making a slideshow. I had no idea. So I'm going to do this. By the way, my finder's already pointed to this folder, but basically I just need to find my processing sketch, which is here on the desktop under GIF Loop. I saved everything into output. And then so now, if I click here and do Command A for select all and open, it is now uploading all my files. Look at this. Ooh, this is so cool. So look, now I can see all of the images. And I could delete some, I could change them, so I can do some like editing here. And then if I want the whole thing to be 1 second, interesting. So like I could change this. Is it giving me like a preview? That's the preview. Ooh, this is very, very slow. Oh, I want each image to be 1 second. I do not want that. So if I want like 30 frames per second, then I want each image to be, oh, I guess I have to use the slider. Wow, is that like the only options I get? I can only do 10 frames per second? Seriously? It doesn't let me have any more control over it than that? That's not good. I guess that's kind of reasonable to do, but I want to have a faster frame rate. Well, let's at least see if this works. Continue to decorate. Oh, 15.9 duration exceeds maximum 15 seconds. Well, no. So this GIF maker is no good. Apparently we need to, the old website was better. All right, let's go back to that. No wonder Golan didn't recommend this one. All right, here we are. Can I just drag and drop it, by the way? Just curious if it lets me do that. No. That would be nice, wouldn't it? All right, I found this website. Thank you to the recommendation from Golan, gifmaker.me. There are so many different ways you can make a GIF. You can do it in Photoshop. I will include links to other websites that allow you to do this. Giphy has one, though it has some limitations. I just found out because I just tried it. And what I need to do here is click this Upload Images. And basically, I want to take this folder and upload all of the images I saved out to that website. So I am now going to click Upload Images. Luckily, my browser is already into that folder. I wonder why. But you would have to navigate to find it. I'm going to hit Command A, which does select all, open, and then now I wait for these things to upload. It uploaded. And now I take my GIF out of the oven and present it to you here. All right, so we can see that it's going, it's very, very slow. So if I want it to be, that's because it is, the animation speed is 500 milliseconds, which I assume is the amount of time for each image. And I believe 30 frames per second would be like 16, is that right? So if I do that, we can see, that looks right. So that's like 30 frames per second. And then I want to do create GIF animation. Click that. Please wait a moment. Then I'm just going to click view the GIF, and it opens up a new tab. That's still really slow, right? That's not 30 frames per second. Why is this not working? All right, let's try downloading it, see if that helps. So now I've downloaded the GIF. Is that 30 frames per second? Is it just that and it's just like when it's smaller, it looks so much faster? 16 is 60, yeah. 16 is 60, sorry, yeah. Yeah, it's 16.77 probably. FFmpeg. Yeah, I was just trying to avoid like FFmpeg because it's like a whole thing people have to install. Gizmo.com easing. Is that for making GIFs or that's for easing? Change the animation speed before you upload the image. Last time I used 10. Yeah, I guess I could use Photoshop. I wanted to use something that everybody could use. Not everybody will have Photoshop. And not everybody, all right, let's try easy GIF/maker. That's another one. easygif.com/maker. This is try number 15 million. All right, let's try this. Okay, let's try this. All right. Can I please make my oven joke one more time? All right. You can use, yeah, we're trying to do something that you don't have to install and you don't have to pay for, although these things have like ridiculous amount of ads on them, but. Okay, let's see. All right, we'll try this. Okay. All right, so now that I've made all those images and saved them to the output folder, I'm going to try stitching them together as a GIF. I'm using this website called easygif.com. It must be easy because it says so. So I'm assuming this is going to work great. But there's lots of other ways. You can use Photoshop. You can use FFmpeg. There's all sorts of different tools, software tools that you can use to stitch images together into a GIF. But let's see what happens if I select Choose Files. Luckily for me, it's already going straight to my output directory, but you'd have to find that on your through your Finder or whatever operating system you're using. I'm going to do Select All. I'm going to click Open, and then I'm going to say Upload and make a GIF. And this is going to work, right? Oh, look. So we can see, oh, look at this. We can see all of it. The delay is 20. So 20 milliseconds would be, I guess that's like somewhere between 30 and 60 frames per second. And somewhere here, I should be able to say Oh, I can change the delay time. So 60 frames per second would be like 16.7. Let's just leave it at 20. Loop count, loop forever. I'm not going to worry about, I'm not going to crossfade frames. So it's interesting that it has that effect. Let's try this make a GIF. Oh, I have to wait now. It's baking in the oven. (32 is 30 frames per second. Very slow. Oh, that's in 1/100th of a second. That's not milliseconds. Okay, it says right there on the page, in 1/100th of a second. 1/1000th of a second is a millisecond. So like 32 milliseconds of delay is like maybe around 30. Let's make this 3. We want 3/100th of a second. Let's just try that. Let's see what happens. I mean, you might want it slower, but I want it to kind of like look like how it looked in processing. So let me click this again. There we go. Look, there's my GIF. There's my GIF. Is it perfectly looping? It's sort of hard to tell, but now I should be able to download it. I can probably just like right click and do save image as and say put it on the desktop. And then I can look at it here. And there it is. Yay, I made a GIF, I made a GIF, I made a GIF. Okay, so you get the idea. Oof. What to show you next? I don't know if I really want to show you much more. Makeagif.com pictures to GIF. Okay, I know. All right, so ultimately, the creativity of what you design is really the thing that I'm hoping that you will discover in yourself to make something. I mean, I've just made a rotating square. But I think in order to be able to explore your creativity, you're going to need the tool you're working with to be a bit more flexible. Because right now, the way that I set this up is it kind of runs it once and then quits. But I really want to be able to watch the thing loop and then like change the code and run it again and change the code and run it again. And then when I'm ready, kind of hit record. So let's do that this way. I could do that through an interface, but I'm just going to make a Boolean variable called record. And I'm going to set that equal to, right now I'm going to set that equal to false. Okay? So what I'm going to say here is if, I'm going to say float percent equals 0. And this is very similar to Golan's. If record, then I am going to use this counter that I have. And then I am also going to do all this stuff like saving the frame. Otherwise, I am just going to say percent equals float, the actual frame count. I mean, I could always use the counter. This is silly. I should just always use the counter. But frame count modulus total frames divided by total frames. And so this should really be, this is a little bit goofy, but I'm going to put the percentage around here, the parentheses around there. Okay, so let me give myself a little bit more room to look at this code. This is weird. I gotta explain this for a second. And why? There we go. Okay. So what I want to do here is I want to have the frame count always cycle back to 0, and I want to, which I use the modulo operator, and then I want to divide that by total frames. But I want to convert that into a float. And so I don't need these extra parentheses or this parentheses. Yeah, no, yes, this is what I want. Sorry about that. This is what I want. I want to do frame count modulus total frame. This is so silly. I'm just going to use the counter for everything. There is a built-in frame count variable. And so really, so it's really just about whether I'm using the modulus or not. This really
I will refactor this later, you know. I will refactor this
All right. So now that recording is false, this is just going to play the loop forever and ever again. And I know that if I ever want to now record it, right? If I like my design, I can go and delete what was there before, which I don't have to. It'll overwrite it, and I can change recording to true, and then I can run it. It will do the recording, and then it will quit out. So there you go. You know what? There's a mistake here. I am recording the last frame, and I don't want to. Let's look at the output here. Yeah, 120. I don't want 120 because 119 is the frame right before the starting frame, the way that I've coded this. So this save frame has to be here. So that's a quick fix. Let me delete that again. Let me run this. Here it goes, record. It's going to draw that last one, but that's fine. Now we should see the very last. Shouldn't it exit before it does that? It didn't. All right, well, let's do it this way. Let's just check if it gets to the end. If it gets to the end, the frame before the last one, then quit. And now, here we go. That worked. I can see just based on where it stopped. Okay, great. So this is what I want. I want the last frame to match up before the first one. Okay, great. So there's so much other stuff we could do. I could use like a sine wave. Again, I would encourage you to look at different easing functions and try all sorts of different kinds of designs. And your only limitation for yourself is that the end matches up with the beginning. But matching up can mean a variety of different things because something can leave the window and then enter again. So there's as long as there's a visual continuity, your GIF will loop. So I will come back. I will show you also how to do this in P5.js in the browser with a special new P5 GIF library that I've been testing thanks to the creators of that library. And I'll come back and show that to you in a future video. And please, share your GIF loops. We're going to have them all over the place. I don't know. Coding train GIF loop? No, what should it be? Just share them. Just look at this video's description. I'll explain how to share them. Goodbye. Thank you. Oh, was 120 still there? Wait, hold on. And I just didn't delete it? Let's see. I'm pretty sure I deleted it. I feel like I need to do this whole video again. No, isn't that weird? It's, even though it exits, exit is like, it must be asynchronous or something. Because oh, you know what it must say? It must say, it says exit when you get to the end of draw. So draw, it's probably more like an indicator. Like if I really did, I wonder if I did like system.exit 0 or something. Yeah, that worked. Interesting. So the processing exit function makes sure that draw finishes. That's an interesting little tidbit. Make sure that draw finishes, whereas system.exit actually forces the exit. GIF train. But it's like a gift. Please share your GIFs with me. Hashtag GIFTrain. It's like a gift in the rain. See you next coding challenge. Goodbye. Yeah, I see what you mean. This is so flawed in so many ways, but I'll decide if I need to come back and do this again. All right, let's make some more hearts. Oh, it's 1 o'clock. Let's make a few more hearts. Oh, I could say return. That's a good idea. Let's make some more hearts. So many hearts. Let's make some more hearts. And we can make it a GIF loop. All right. Okay. All right, everybody. All right. Here we go. It's time to finish up for this week. Oh, I wanted to talk about the data course. I never get to it. I really have to work on that. Oh my God. Oh my goodness. Oh my goodness. All right. Do I need, I'm not so sure that I need the board, but in case that I do, I guess I should erase. I think that GIF loop video is like kind of useless, but we'll see. Sometimes I think that and then I'm in my own head because, and actually maybe there's a lot of stuff that's like new concepts for people. Okay. All right. I love you. I'm here to make some mathematical hearts. Look at these formulas. If you plot these formulas, you get a heart. I mean, what could be better than that? This one here might be my favorite, although this one here is kind of interesting. Look at this. So we could try any of these, but I actually want to try something a little bit different here. I mean, I'm looking at this and I know what formula are there, so what I'm about to do is in no way magic whatsoever, but I want to try to get a little bit of an intuition for why that crazy formula makes a heart shape and how you might basically design your own parametric equations to generate different patterns. So there are a variety of different techniques for this. Oh, look, rotated cardioid. Oh, I love the cardioid. I have a whole video about the cardioid. And we could just graph the cardioid just with like 1 minus sine of theta. So many ways we could make the cardioid. But let's go to processing. My happy place, my love, my true love, processing. Can I put like emojis in the comments? Hold on. Heart emoji. Mathieu, you're going to edit this part out. Let's just see if I do copy. No! I cannot put emojis in the comments. It's so sad. What did we do before there were emojis? Like this, right? Okay. Now that we've gotten that out of the way, that was very important. I'm going to go back to the curve thing. So first thing that I want to do is this is going to be a lot easier if I think of everything as oriented around the center of the window. So I'm going to translate the origins in the top left. I'm going to translate to the center. By the way, this channel, I shouldn't call it the coding train. I should just call it Here's another example of things you can do with polar coordinates. Basically, like every video I make, it's the same. But maybe that's the theme for this week. So now what I want to do is I want to loop around all of the points of a circle. You'll see why in a second. I want to say for float a, which stands for angle. I'm going to start at 0. I'm going to go all the way up to 2 pi, and I'm going to go by some increment. I'm going to pick that arbitrarily, although there might be reasons why I want to pick different increments at some point. So I'm going to have every angle from 0 to 2 pi, and I'm also going to make up a variable called r, which is kind of like radius. Let's just set it to 100 right now. And I'm going to say, once again, here we go, sing it with me. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. R times cosine of the angle, y equals r times sine of the angle. What I want to do here is I'm going to say no fill and stroke 255 and begin shape, because what I want to do is create my own custom shape based on all of these points oriented around this circular path. Hopefully this will all start to make more sense to you. So then I can call vertex xy, and then I can say end shape, and I can run this, and you have this, a circle. Ta-da! I have made a circle. The circle, and by the way, if I were to change this increment value to something much higher, you can sort of, well, let's make it like much more extreme. You can see here, like I'm actually just moving around the edges of a circle, and if I thought more carefully about like 2 pi divided by 6, then I might have a hexagon, all sorts of possibilities like that, right? 2 pi divided by 6. There we go. Nice little hexagon there. But this is not what I'm doing. I am just tracing the contours of the circle. Now, here's the thing. I can start to futz with these equations. For example, what if I wanted it to pinch a little bit? Hold on, pause for a second. You can put an emoji in JavaScript. Sorry, I'm seeing some comments of other equations. Yeah, this is the one that I'm doing, the system one, Simon. Okay, hold on. Okay, sorry. All right. So what if what I wanted to do is like pinch the shape a little bit? So interestingly enough, what if I say like cosine of A times cosine of A? Let's see what that does. Oh, weird. So you can see what that's doing. I'm squaring the value. So it's kind of squishing it a little bit along the x-axis. But of course, everything's on the right side, because if I square a negative, I get a positive. But I could go to the third power. So why don't I say power of cosine of the angle to the third power? Look at this. So you can see, like, even just doing that gets me this diamond-like quality. So that's really working for the bottom of the heart. In a way, that's the bottom of the heart, but I need to change the top. So I need to think about what I'm doing with the y. So again, I'm just kind of, this is very, in many ways, like similar to my Fourier transform epicycles videos. There's like conceptually tied here in that I'm messing with the oscillating values as I move around this kind of circular path. Now, let's do something else. Like, let's say, well, what if I take sine and I for the y value, what if I kind of multiply itself by sine of the angle, but have like the frequency doubled? So if I do this, right? Well, that's interesting. Look what kind of shape I get there. What if I multiply it by like a much more extreme amount, like 5? Whoa, look at that. So things are starting to happen. And probably actually what would be much smarter for me to try to visually demonstrate this, I have to think about this, would be to animate the process of this and actually show the separate x's and y's moving, similar to the Fourier transform videos. But I'm going to kind of move from here, and I'm looking over here because I have the actual formula from that Wolfram page that I started with. You can sort of see here, okay, look, if I have, and this is actually using sine for x and cosine for y. I think that's just going to like put it on its side, probably. But let's so let's put some more stuff in here to like think about. Let's look at this. So 5 times, starting with 13 times. Okay. So changing the amplitudes as well. So if we do this times a times, well, let's just. GIF train. Yes, Espen, it is GIF train. I probably should have just put the formula in. I don't know why I'm doing it this way. I thought this would be interesting. Classic villain mustache. The chat is saying that instead of a heart, I've made a classic villain mustache. All right, I think it's time for me probably just to put the formula in. It's sort of interesting to explore the different possibilities here. But ultimately, if I'm seeing this equation, what I want is why these interesting numbers, right? Well, I'll get to that in a second. But let's do cosine of t. Oh, minus. I don't want to multiply this stuff together. Losing my mind here. So I want to subtract out. Yes. So as I'm getting to the top, depending. Okay, so this makes sense. So let's actually put this stuff in. Let's change this to cosine. Let's change this to sine, right? No, let's change this to sine. Sorry. Let's change this to cosine. I guess I already had done that. And then I'm going to say cosine. And this is like I've got a 2, a 3, and a 4. 2 minus a 3 minus a 4. So you can see what's going on here, but I need to. You can see that it's now actually a little bit more squished at the bottom than at the top. And so what might be interesting here is to think of this as, well, if this is r, then maybe I want r times 2 times this. Whoa, look at that. Because now when it comes down, but you can start to see the heart, but it's upside down. So I kind of want -1 times the whole thing because of the way the processing coordinate system is. We can see, look, I'm kind of getting a heart there, but I've gone to extreme. So I should probably get rid of this r thing. Let's just make r1 and use the actual numbers. So the actual numbers in the formula are 13, 5, 2. So I can say 13, 5, whoops, 5 times, 13, 5, 2, and then cosine of 4a just is not multiplied by any factor. So now if I do this, let's put parentheses around. What am I doing here? Got too many parentheses here. This. There we go. Hey, look, there's the heart. Oh, I love you, heart. And then now I could scale it up by a factor. I mean, I could just use the scale function, but I could have, basically scale it up by 10. And then I could say -r times that. And there we go. So now we have made the heart. Let's animate it. This was very silly, my whole trying to walk into this formula. Really, I just want to look it up. But let's animate it. Let's have it trace the path of a heart, because that'll be really nice. So what I'm going to do now is I'm going to create an array list of p vector objects. So if I were doing this in JavaScript, this would be a much simpler, just plain array. And then what I'm going to do is I am going to not have this loop anymore, but rather have a global variable called a. And I am going to do the same exact thing, but I am going to say here, the for loop, the for loop will be for every p vector v in the heart. Draw a vertex at v.x, v.y. And then what I'm going to do is each time through draw, I am going to make a new vector. I'm going to say heart.add new p vector at some x and y, and then I'm going to increase the angle by a little bit. So here we go. Mwah. Bing! Yay! Okay, so I made a heart with math. I mean, this makes me so happy. My artistic talent is non-existent, but let's at least make the stroke weight a little thicker. Let's add a fill. Someone give me a nice red color, but I feel like it should be like a little bit more, a little darker and a little pinkish. So let's try that. And let's make sure I add close here so it closes the shape. Whoa, oh, look at that. Oh, no, 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 no. I do not want close. I specifically do not want close. Yes, that's what I want. And now we are making this heart. Yay, I made a heart. I love it. So I challenge you to go and look at these other formulas and try them. Simon Tiger has shared with me a ton of other formulas. Maybe I'll see if any of those I want to try. But you find a formula and make your own heart. Could you do it in 3D? I bet you could make a 3D heart, all sorts of stuff. And share that with me. Coding hearts, hashtag coding hearts, coding love for this wonderful, any day of the year. We should be making hearts all day of the year. No reason to just do it in February when it's cold outside and there's always like snow and sleet and everything. Anyway, I love you. Thanks for watching The Coding Train, and I'll see you soon. It looks a little messy at the bottom. How dare, oh yeah, it does. How dare you insult my heart? I think it's probably because I have just too many points down there. Yeah, that's better. Combining this with the Fourier stuff would be good. Here everybody. R is height divided by maybe like, it was 400 before and I got 10, so divided by 40. Let's try that. Oh, this would be a good GIF loop. Let's make this a GIF loop, everybody. Hold on. Okay, we're going to make this a GIF loop. It's winter, it's a snowflake. Yes. I see that you have some 3D formulas in yours, Simon. That is fantastic. I don't think I'm going to get to those today, but I really appreciate your suggestions. You should make them, and you should make a video about all your different heart formulas. All right, hold on. Hold on. Okay, so hold on. It's time for a Coding Train bonus episode! I made this ridiculously terrible video about how to make a GIF loop, and you should really just go look at Golan Levin's amazing resources and different artists that I mentioned, Saskia Freak and Bees and Bombs, who are doing wonderful things. Then I made this video, which I actually kind of love, that makes a heart in processing, just using like a nice little math formula. Look at that. It's time to make a GIF loop of the heart for Valentine's Day. There, I said it. It's Valentine's Day. This is what we're doing. All right, so first that I need is for this to always end where it started. So I have an idea for doing that, which is that if what I'm doing is I'm adding these, I'm adding the vertices of the heart over and over again, when I get to the end, all I want to do is start deleting the ones from the beginning. So I should go back to that idea of percent. So let me actually open up my other thing. So I'm going to open up the GIF loop code. This is my design, So what I need is this at the top. I'm going to go, I have too many things open. Oh my goodness. I need this at the top. Then I need all of my drawing stuff. I should leave that in there. I need all my I know I'm standing in front of the code, but I'm just copy pasting from the last one. I'm going to get all my drawing stuff, and I'm going to put it in the render function. And now the percent is going to tell me what to do with A. So that angle. I'm going to have to change things. So let's just first do it this way. A equals map percent, which goes between 0 and 1, to between 0 and 2 pi. So right now, if I run this with record, and let me close this. This should just be, I've got my GIF loop. Let me just move everything out of the way. I've got my GIF loop here, and I want record to false, so I don't want to record yet. So now if I run this, we can see it's making the heart. Oh, right. And then, okay, so that's the right idea, but it's not looping. Because ultimately, I mean, there's a bunch of things I could do, because I could say, if I record it, I mean, in a way I'm getting a loop, but I want it to like shrink back down to 0. So I need the size. So basically, I want this to be like, actually when percent is between 0 and 0.5, halfway through, I want to draw the heart. So I'm going to say, this is weird, but if percent is greater than 0.5, is less than 0.5, less than or equal to 0.5, there's probably a better way to do this, but I'm going to do it this way right now. I'm going to add points. Otherwise, I want to remove the number of points that I've added. And I think it actually is just going to work if I just say heart dot, how do I delete something out of, I think if I just delete 0, that'll be like the oldest one. As I get, so let's try that. That removed them all. What's going on here? Oh, but I still need to draw. I always need to draw it. So I'm always drawing it, no matter what, but I'm adding points for the first half and removing points for the second half. There we go. There's my loop. Yay! Okay, so now, guess what? I should add some colors and things. Oh, it should beat. People are saying it should beat. Of course it should beat. Okay, we're gonna add beating to it. Okay, so there's no reason why the size is being controlled by this thing R here. So I should say map. Okay, hold on. The no, that's a totally separate thing while I'm drawing it. So hold on. So actually, let's take this out. Let's take this. So this will make it small, right? Right. So that makes it small. So I can control the size here just while I'm drawing it, because I could say R times. Great. So now what I want is the R to be. So I want an angle to be mapped, but the percent between 0 and 1, and maybe between 0 and like 2 pi, but like times 4. Like I probably want it to like beat like 4 times within just the 1. So I'm going to map that, and then R equals map of sine of that angle, which goes between -1 and 1 to between like height divided by 80 to height divided by 40. So I think this would like map the size to a sine wave, and the angle is getting mapped from the percent. And so this would be, and it should be a perfect loop of it beating. Okay. I feel like I need to add more color and stuff to this, and it's kind of off center. All right. So let's see if this is a perfect loop. I have no idea if it's a perfect loop. It's weird. Something was weird about it. Oh, something is weird. It's not deleting all the points. This is crazy. This is actually kind of a nice effect. but I'm not deleting all of the points. I did, and am I just getting like some left over? Hold on. Let's make R, I think I thought the math would just sort of work out. Let's take out the beating for a second. Whoa. Oh yeah, it's not, you can see there's like an extra point each time. So it actually kind of works the first time, but I think I need to remove, else remove the heart, and then I think actually here, if, where do I check? I guess if percent, is it going to get to exactly 1.0? Let's say greater than or equal to. I mean, then heart.clear. No, it's still getting an extra point. Oh, weird. Why is that point in there? It doesn't, else heart remove. Wait, I have to think about this for a second. Pause. Ooh, look at that 3D heart. The point for percent equals 0.5, yeah. Right, right. This is flawed. I mean, I think it'll actually work when I record because it's just doing it the first time, but I would like it to actually loop. I'm just thinking about this here. Otherwise, remove. I just want to just be sure this is the issue. All the way down to 3, all the way down to 4. Yeah. It's got extra points in it. So why are there not the same number of frames? Oh, it's as simple as that. It's as simple as that. Guess what? The problem is I'm adding an extra, I'm adding that last vertex twice because I have less than equals there. So this is actually as simple as just getting rid of that equals there. I just want to use percent is less than 0.5. I'm sure somebody in the chat already said this, but now you can see this loops perfectly. So now what I can do is I can change, let's make sure there's nothing in the output. Let's delete whatever was there before. I can change record to true. I can run this. And now we should see, if I look in output, if I look at all the images, and I scroll through them, and let's just look at the very last one, you can see, yep, it's kind of, that's the end of it. So now I can go, and I might edit this part out, but I'm going to go to, or we can speed this up, but I'm going to go to, what was the website I used? Easy GIF Maker, yes. So I'm going to go to this website, easygif.com. I'm going to choose some files. I don't need to, I'm going to, where is this now? Are these the hearts? Yes, those are the hearts. I'm going to hit open. I'm going to upload and make a GIF. It's got those files. I am now going to change the delay time to, let's just make it 3. That seemed good from before. 3/100ths of a second. Make a GIF. My cat is there making the GIF. Making the GIF. Oh, the beating! Ah, the heart beating. Shoot! So I'm going to go from where I hear. So let me also add the heart beating back in. I'm going to add, where was that? So I'm going to add the heart beating back in, where I had R change. And that, What time is it? Okay. All right, perfect. All right, let me add the heart beating back in. So I had that from before where I had R mapped to the result of a sine function. And so if I do that, I'm pretty sure this is a perfect loop still. Is that beating too fast? Slower beating, people are saying. So to slow down the beating, I'm going to just do 2 pi times 2. Is that better? I think that's pretty good. Anyway, you can make your own version of this. This is fine for me right now. I got to end this video. I am now going to change record to true. I'm going to hit run. It's going to finish that. I'm going to look in the folder, and I can see I have all the images there. I'm just going to check the last one, which looks like that. And the first one, yeah, I think this will match up perfectly, which basically the first one is empty. So I think coming all the way down to 0 and back up will work. So I'm going to go, the website that I used, whoops, hold on. So the website that I used before, although there's a variety of different ways you can make a GIF stitched out of a bunch of images, is this GIF maker, easygif.com/maker. So I can click choose files, and I can go to my output directory where I have all those. I can hit Command A, select all the files, and then click upload and make a GIF. So it's now uploading all those images, and we can see them all here now. I could do all sorts of things to futz with them, and I'm curious to add this crossfade frames. Let's try adding that. Oh, that's a bad idea. I don't know. Let's make the delay time 3/100 of a second. That's more like 30 frames per second. And then, I mean, it's not exact, and then I'm going to click make a GIF. And then the cat is going to, I'm going to wait for my GIF. Hi, cat. Meow, meow. Make me my GIF. Meow, meow. Ah, the camera went off. Oh, and my GIF is ready. Yay. Now I can just do save image as. And I'm excited to tweet this. Heart. And I'll tweet it later. There we go. This is done. There's my, no, that's not it. Where did I put it? Heart GIF. There it is. Thank you, everybody. I love you. I hope you enjoyed this special about this video about using math to draw a heart curve and then animating it as an infinitely looping GIF. And I just can't wait to see all of the different, I just want to be flooded with heart GIFs. Just flood me with heart GIFs. Make them 3D, make them rainbow colors, put stars in them and cupcakes and whatever you can think of. I'll see you in a future coding challenge. Goodbye. Mwah. Oh, wait. What's the difference? Oh. Okay. Oh, I love that 3D heart picture. Okay. All right, everybody. Yes, finally can go pee, says Bharagava Chopakatla. That's how I feel as well. Finally I can go drink. I forgot to bring water with me today. So I'm excited. There's a bunch of videos that can come out. I will see you in, oh, hi, Coding Garden with CJ in the chat. Everyone should check out Coding Garden with CJ's channel. Let me do any more thank yous that I might have missed. Okay, thank you to all the other people who watched Heart GIF Train. I don't know, I think I'm done for today. I will be back next Wednesday. I haven't checked my calendar, but this is my plan now. If you're watching this right now, I am going to try to have, at least for the next few weeks, every week. So the way that I work, until someone tells me not to do this way anymore, is I do a live stream every Wednesday at 10:30. I do a bunch of things during the live stream, And then wonderful Mathieu Blanchette, who works as the editor for the Coding Train, takes everything from the live stream and chops it into separate smaller videos, which then get uploaded into different playlists, whether it's coding challenges or courses. I actually made a video yesterday that was not live streamed. It's like a little extra beginner lesson about create graphics in P5. So I might even upload that this afternoon. But I just want to highlight, I think I'm like a little bit stuck here. Data and APIs, Schiffman, GitHub. Please come and, let me just go to, oh no, it's on Coding Train, GitHub. I am planning, I should pin that repo. Here, it is already pinned. I am hoping to make a new playlist, and I've been getting suggestions and discussions about what I might include in this. I think it's probably going to be approximately 10 to 15 videos, and I want to cover really about working with data and APIs in JavaScript. So things I haven't covered before or things that I covered before that are kind of out of date now for a total beginner. But the focus won't necessarily be P5. So I will also teach about the fetch function and also look at data and APIs in Node. And I will use P5 to do some drawing stuff. But at some point I'm going to make an outline. But if you have suggestions or things that would be good, bite-sized, beginner, and data sets I'm looking for, because I want to look at something with like a CSV data set, a mapping data set, and maybe a news API. These are the kind of things I want to look at. Okay, thank you everybody. I will see you next Wednesday or on the various uploads that come. I'm so thrilled to have had this strange thing happen to me in my life that I am here making videos on YouTube about coding and getting to be completely ridiculous if I feel like it, which nobody seems to have complained about too much. I get complaints. A lot of people are like, you should take yourself more seriously, and or like what kind of like whatever substance are you using to be this weird way that you are? And I can assure you that it is just a mild chamomile ginger tea and caffeine. I do drink a lot of things with caffeine in that. All right, goodbye. I am going to sing you out with new member Espin.
I will refactor this later, you know. I will refactor this later. I will refactor this later, you know.
Oh, wait. Mathieu always says, give me some green screen shots of for thumbnails because, oh look, it's my invisible computer. This is what people, I'm really just going for clicks, right? Clickbait expressions. All right, that's good enough. Goodbye, everybody.